Let's look at an example of an application involving a parabola as a conic section. And one of the common examples that we see of parabolas is that they relate to um, the shape of the suspension cable in a suspension bridge. And so in this particular example, we want to consider the Golden Gate Bridge, which is in California. And it's a suspension bridge that consists of two towers that stand up out of the water. And so the two towers are about 4,200 feet apart from each other, and they both stand up about 746 feet above the water surface. Now, again, that 746 is probably an average, right? Because water levels are going to change over time. But let's just say it's 746 feet above the water, and they're 4,200 feet apart. The road surface is also roughly about 220 feet above the water level. What we want to do is figure out how high are the cables above the roadway, not above the water, but above the roadway at a distance of 500 feet from either of the towers. Okay, and we can pick whichever tower we want because the parabola is going to be symmetric. Okay, so we have an illustration that goes with this. Again, we have this parabola shape. And for the Golden Gate Bridge, the vertex of that parabola is roughly touching the road surface. So it's about the same height as the road surface. And I know that road surface is 220 feet above the water. The two towers on the left and the right, they are 746 feet above the water. And so again, the distance between the road down to the bottom is 220 feet. So from the road surface down, that's 220 feet. And so what is the distance from the road surface up to the top? Well, if the whole thing is 746, then 746 minus 220 is going to be 526 feet. So from the roadway to the top of the tower is 526 feet. Okay. We know the distance between the two towers is this 4,200 feet down at the bottom. All right. So just looking at this problem, we're wanting to connect this to a parabola equation, but this illustration, this picture here, gives us nothing related to equations. Okay. To have an equation, we needed an x and y variable, x and y values. Well, this illustration just measures distances. There are no x and y. I don't know where the x-axis or the y-axis is. I don't know where the origin is located or anything. So as we solve this problem, I need to take this illustration, this graph there, this picture that we're given, and I need to locate it on the xy plane. Okay, I need to figure out where's the x and the y axis. Where is the origin? And there are multiple places we could put that. Usually the easiest place to locate the origin would be to put the origin at the vertex of the parabola. And so I'm going to go ahead and do that this time. So I already know that the roadway actually passes through the vertex, right? So I'm going to call the roadway the x-axis, and then I'm going to draw a vertical line passing through the vertex as well. And so this is going to be the y-axis. So the vertex of our parabola is going to be at the origin. So that means that I have a parabola that is opening up, so it's oriented vertically, and its vertex is at the origin. So our standard equation for a parabola opening vertically, our standard equation for a parabola opening vertically or horizontally would be x squared equals 4py. And again, this is assuming it's at the origin, which is the assumption I made. I went ahead and I tried to locate the vertex at the origin. Okay, I don't have to do that, but again, I think it'll make life a little easier to work with. Now, To write the equation for that parabola, I need to figure out the value of p. And we've done a similar example in some of the other problems that we've looked at. In order to figure out p, remember p is the distance from the focus to the vertex or from the directrix to the vertex. Well, in this problem, I don't know anything about where the focus or the directrix are located, so I can't use that relationship. However, if I knew another point on the curve of the parabola, I could plug those into the equation, the coordinates into the equation, and I could solve it for p. So looking at the illustration I have, now that I've located it sort of on the xy plane, I know where the x and y axis of the origin are, can I locate another point on the curve? And yes, we can, right? I know this parabola shape has to pass through the origin, which is the vertex. The bottom of the parabola is at 0, 0. And the parabola also has to curve up to the top of the two towers. So both of the towers would correspond to points. The tops of the towers would correspond to points on the parabola. I don't need both. I just need to pick one. Okay, so let's use the one on the right. I need to figure out the x and the y coordinate for that point at the top of the tower on our curve, assuming that the origin is at the vertex. Well, if the whole tower, or the distance between the left tower and the right tower, is 4,200 feet, then that means the distance from the center, from the vertex to the right, is half of that. So that would be a distance of 2,100 feet. Okay, and so that would be the x coordinate, the x dimension for my tower. So 2,100 feet. Okay, and then we also need to know the y value. So the y coordinate, the y value would be the distance from the x-axis, which is the roadway, up to the top. And we already talked about this a few minutes ago. We know that that distance is 526 feet. So I now know a point on the curve that's not the vertex. It's the coordinate 2,100, comma 526. So I know a point on the curve. I can plug those values into my equation and solve it for p. So I'm going to plug 2,100 in for x. I'm going to plug in 526 for y. So we'll have 2,100 squared equals 4p times 526. And then we just need to simplify that to solve for p. All right, some of these numbers get kind of big, so I'm not going to write out everything, but we're going to leave this 2,100 squared as is, but I'm going to multiply the 4 times the 526. 4 times 526 is going to be 2,104. So we're going to have 2,104 times p is equal to 2,100 squared. And to isolate the p, I'm going to divide that 2,104 over. So we're going to have 2,100 squared divided by 2,104, and that's equal to p. And just to kind of get a simpler, maybe decimal, we'll round that as a decimal, p is going to equal 2,096.01. Let's just round that to the nearest whole number. So we're going to say 2,096. That's our value for p. And again, that's approximate value. We've rounded it to the nearest whole number. So that is a positive p-value, which corresponds to the graph opening upwards. It's the distance from the vertex to the focus and the vertex to the directrix, which I'm not worried about finding those here, but just remember that's what that looks like. So to write out our equation, I'm going to have x squared equals 4py, and I know p is 2,096. So we're going to have x squared equals 4 times 2,096y. And if I take 2,096 times 4, we'll have x squared equals 8,384y. So that is the standard equation for our parabola with its vertex at the origin. And so that hopefully is the parabola equation that describes the curvature of the shape of these the suspension cables for the Golden Gate Bridge. Okay, but we're not done. We have our nice equation, but what are we trying to solve? We want to figure out how high the cables are above the roadway 500 feet from either tower. So if, say, we look at the right tower, if I move in 500 feet, so the distance from that right tower to the left, we're going to move to the left, that's 500 feet. I want to know what is the height of that tower. Okay, well, the height is really just the y coordinate. So I want to know what is the y coordinate for that point on the curve. Okay, well, if that's the y coordinate, what's the x coordinate? The x coordinate is not 500 because the 500 is the distance from the tower. X coordinates are distance from the origin. So if it's 500 from the tower, how far is it from the origin? Okay, well, I know the whole width is 2,100. So what's 2,100 minus 500? So 2,100 minus 500 is going to be 1,600. So this coordinate has an x value of 1,600 and a y coordinate that I don't know. And that's what I'm actually trying to find. And I know it's the y coordinate because that's the distance from the roadway, which is the x-axis, to the curve. So I want to take this coordinate of 1,600 for x and y for y, plug it into my equation, and solve for y. So to do that, we're going to take my general equation, which was x squared equals 8,384y, and I'm going to plug 1,600 in for x. So we're going to have 1,600 squared is equal to 8,384 times y. I'm not going to work that 1,600 squared out. I'm just going to leave it there, but we're going to divide both sides by the 8,384 value. So 1,600 squared divided by 8,384 has to equal y. And if we compute that on our calculator, we will get a value for y of 305.34 feet.